Today we're going to take a look at the counting sort algorithm challenge presented by Topcoder. Now, counting sort is a variation of bucket sort. Bucket sort will take each array and create its own bucket for each item in the array. Now, this item in an array can be anything from strings to integers to floats to whatever. Counting sort, however, deals primarily with numbers, with integers. And what it does is it creates buckets that can be used to hold a count of the number of items in the array. And each of those items in the array, each of those integers in an array is a key to that bucket. So when we start building our output array, we're going to concatenate or insert the number of those keys that we have counted in a counted array. So let's go ahead and take a look at this real fast. And what we're going to do is we're going to print out to the console what's being built with each of this counted array. Now let's talk about the algorithm real fast. Now the input that's coming in is going to be an array of integers. And should that array be empty, then the array is technically sorted and it's just going to return that empty array. Now, if the array is not empty, what it's going to do is it's going to find the minimum and maximum values in that array. And it's going to do this by using Ruby's built-in min-max method for arrays. After it sets those two values, or those two variables, it's going to then create a count array. Now this count array is this container, the organization of buckets for this array. And it's going to only create the number of buckets as the numbers between the range of the min and max. So for example, if we have an array that has, let's say, 3 numbers in it, 1, 3, and 9, then what it's going to do, the counting array will then create a new array with 9 units in it, and each of those units will be set or initialized to 0. And we get the number of units by taking the maximum, subtracting the minimum, so 9 minus 1 is 8, and then we add 1 more to it, so that's 9. So let's go ahead and do that real fast. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So that should be 9 total items. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 total items, and they're all initialized to 0. Okay? So that is the initial counting array that we've created. Now, once we have this counting array built, what it's going to do then is it's going to iterate over this input array. So let's say our input array is 1, 4, 1, 5, 7, 2, 7, 9. Okay, so we have 8 items in this array, and the min is going to be min is equal to 1, and max is equal to 9. Okay, and so again, we still have 9 items that are going to be built into that count array, initialized at 0, and then it's going to start iterating over the input array that we pass in. And so for each number in the input array, it's going to take that number, and in the count array, it's going to find the index, and that index is going to be the number that's passed in minus the min, and it's going to add 1 to that item in that count array. So the first number that's passed in will be 1 here. So 1 minus 1 is 0, so at count 0 we're going to add 1. Then 4 minus 1 is 3, So at count 3, so 0, 1, 2, 3, we're going to add 1. Next number is 1 again, so at index 0, we add 1. Then the next number is 5, so 5 minus 1 is 4, so at index 4, we're going to add 1. Then 7's passed in, so at index 6, so 0, 1, 2, 3, 4, 5, 6. At index 6, we're going to add 1. And the next number is 2, so at index 1, we're going to pass in or add 1. Then 7 again, so add 1 to index 6. And then 9 is passed in, so we add 1 to index 8. Okay, so this is our new count array after all the numbers from the input have been counted in. Now we take this count array and what we're going to do is starting at the min, which again is 1, through the max inclusive, that range, with each of those numbers in that min to max range, we're going to pass in an object that is going to be the output. Now, as we pass in this object, what we're going to do then is we're going to start concatenating each of these numbers from the input into that object, which again is initialized as an empty array, and we're going to count or concatenate that number or that item, the number of counts that we have in our count array. So as we're building up this output, it starts with an empty array. Then at the minimum value, which is 1 in our array, we have 2 items. So we're going to concatenate 1 into this empty array 2 times. So our new output would then be 1, 1. The next number is 2. We have 1, 2, so 1, 2 is passed in. Then the next iteration is 3, but we have 0, 3, so this array doesn't grow any. Then we have 1, 4, then 1, 5, oops, 4, 5. Then we have 2 7s, or 0 6s, so no 6s are passed in. Then 2 7s are passed in, 0 8s are passed in, and finally 1 9. And then we have our sorted array. So let's go ahead and see that in action. Now what I want to do is I want to print my count before I put any numbers in, and this is going to show that empty count array. Then after each of those numbers have been counted, I want to go ahead and print to console that count again so we can just see that count that's being put in for the input. Then finally, as each number is passed in, what I want to do is I want to print to console the output array as it's growing so we can actually see what's happening to this output array. Now you'll notice that the counting sort is not an in-place sort. You have to have this array of counts, and you have to have this new output array that grows as we're building it up. So it's not an in-place sort. We're not just moving numbers around into the from the input array into various locations. So again, we are actually taking up a little bit more memory with this counting sort. Okay, so let's go ahead and run the counting sort method, and we're going to do this by passing in just an array of numbers from, well, I'll shorten this when we get it in there, but we're going to pass in a shuffled array from -10 to +10. And we're only going to pass in 10 numbers, and again, these are going to be 10 random numbers between these two values, and we're going to see what happens. Now, of course, the first thing that we're going to see is this random array, so the numbers that are passed in, that will be our input, and then we'll see the count array, and the count array with the counts in it, and then we'll start to see the array as it's being built. So let me make this a little bit bigger so we can actually see these. Okay, so our random array that's been passed in is 7, -6, -4, -4, 9, -1, -6, -1, 9, and -1. So if we want to take a look at our arrays here, we can see that our minimum value is -6, and our maximum value is +9. So 9 plus 6 is 15, plus 1 is 16. So we should have 16 places in our counting array. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we see we have 16 buckets that have been created. And these buckets, again, are our counts. And then we'll just start building up the counting array. So the minimum value was -6, and we have 2 -6 that are built into this array. Then we have 0 -5s, 2 -4s, 0 -3s, 0 -2s, but 3 -1s, 0 zeros, 0 1s, 0 2s, 0 3s, 0 4s, 0 5s, 0 6s, 1 7, 0 8, and 2 9s. Okay, and then once those numbers have been passed in, we start building our array. And so this is the iteration from the minimum value to the maximum value inclusive. And so let's build our array. So to this first empty array, we're going to concatenate the minimum value, so that's -6, and we're going to do it 2 times because that's in our count here. So we get 2 -6s. Then we have no value for -5, so that iteration through the loop doesn't grow our output array. Then we have 2 -4s, so we see our output grow. 0 -3s, 0 -2s, but we have 3 -1s, so our output grows again. 0 zeros, 0 1s, 0 2s, 0 3s, 0 4s, 0 5s, 0 6s, 1 7, and so our output array grows now. 0 8s, and then 2 9s. So all of our numbers have been passed in at this point, and so our sorted array has been returned: -6, -6, -4, -4, -1, -1, -1, 7, and 9. And so that's how counting sort works. Again, if there are any questions, please feel free to ask in the Top Coder forum, and I'll be happy to answer them as soon as I possibly can. Thank you.